Hello everyone. Welcome to the mini lecture on advanced manufacturing technologies for welded structures. I'm Huan Bin. Today we will learn the relevant content of robot welding defects and quality control together. I hope that through this lesson, you can have a clear understanding of the common defects in robot welding and its quality control methods. First, let's look at common defects in robot welding. According to GB 6417 1986 classification and description of welding defects in metal fusion welding, welding defects in metal fusion welding can be divided into the following types. Type 1 is cracks, Type 2 is voids, Type 3 is solid inclusions, Type 4 is lack of fusion and incomplete penetration, Type 5 is shape defects, and Type 6 is other defects. These defects will directly affect the welding quality and the structure reliability. Next, let's focus on the classification of these defects. Cracks include microscopic cracks, longitudinal cracks, transverse cracks, etc. Voids include air voids, shrinkage voids, etc. Solid inclusions include slag inclusions, flux inclusions, etc. Lack of fusion and incomplete penetration include lack of fusion, incomplete penetration, etc. Shape and size defects include undercut, super high weld, excessive convexity, etc. Other defects include arc injuries, spatters, etc. Crack is one of the most dangerous defects in welding, which can lead to sudden fracture of the structure. Porosities in the void can reduce the strength and toughness of the weld. Solid inclusions such as slag inclusions can affect the continuity of the weld. Lack of fusion and incomplete penetration will significantly reduce the load-bearing capacity of welded joints. Shape and size defects include undercuts, super high weld, excessive convexity, etc. These defects can reduce the mechanical properties of welds. Other defects such as arc injuries and spatters have little impact on the structural strength, but will affect the appearance and surface quality of the weld. Next, let's focus on common defects in robot welding and the control methods. The first one is the spatters. Not only does spatter affect the appearance of the weld, but it can also lead to a degradation in the surface quality of the weld. The causes of spatter include unstable arc, fails to meet the welding specification setting, poor welding wire quality, poor welding circuit contact, excessive weldment and welding wire dirt, and improper welding gun operation, etc. For these problems, we can reduce spatter by adjusting welding parameters, using qualified welding wire, ensuring that the welding circuit is firmly connected, and maintaining the correct welding gun angle. Arc instability can be caused by unstable output voltage, unstable wire feeding, poor wire quality, or improper operation adjustment. Solutions include tightening the joints of the welding machine, eliminating relevant factors, using welding wires with qualified chemical composition and mechanical properties, and maintaining the correct height and angle of welding gun. The causes of welding spatter include fails to meet the welding specification setting, poor welding wire quality, poor welding circuit contact, excessive weldment and welding wire dirt, and improper welding gun operation, etc. Solutions include set welding current and voltage correctly, remove or replace weldments and welding wires in time, and maintain correct welding gun angle, etc. Next, we discussed the choice of shielding gas for carbon dioxide gas shielded welding. Carbon dioxide gas is cheap, but there are a lot of metal spatters during welding. Pure carbon dioxide and gas shielded welding, the arc stability is poor, produce more the spatters, and the weld is poor in shape. When welding low alloy steel with pure argon, the cathode spot drifts greatly, which also easily leads to arc instability and porosities in the weld. When we add a small amount of oxidizing gas like oxygen or carbon dioxide to argon, not only the arc becomes stable and the spatters become less, but also the axial jet transition and pulse jet transition can be obtained at a small critical current. Mixed gas shielded welding overcomes these shortcomings and has the advantages of less spatter and high wire deposition efficiency. The characteristics of mixed gas shielded welding include less spatter, large transition coefficient of alloying elements, low oxygen content, large range of process parameters, smooth weld surface, etc. These characteristics make mixed gas shielded welding widely used in robot welding. There are mainly two types of welding wires commonly used in carbon dioxide welding: solid core wire and flux core wire. Solid core welding wire has lower cost and is suitable for general welding. Flux core wire has better welding performance and adaptability. Porosity is one of the common defects in welding process. The reason for the existence of porosities is that the gas generated during the welding process or external gas enters the molten pool, which does not overflow and remains in the weld before the molten pool solidifies. Porosities can be divided into surface porosities and internal porosities, and their distribution includes single, continuous porosities, dense porosities, etc. Types of porosities include carbon monoxide porosities, hydrogen porosities, and nitrogen porosities, etc. The causes of carbon monoxide porosities include unqualified welding wire, impure gas, excessive carbon content of workpiece, etc. The causes of hydrogen porosities include oil, rust or excessive water on the surface of welding wire or workpiece, etc. The causes of nitrogen porosities include poor gas protection effect, excessive wind speed, too small flow rate, etc. Other causes of porosities include splash blockage, loose nozzle, nozzle splash, too large inclination angle of welding gun, excessive stick-out length, etc. These problems can all lead to poor shielding gas performance, which can create porosities. Undercut is the phenomenon that the weld is not well fused with the base metal, resulting in grooves. Undercut will weaken the effective cross-section of the weld and reduce the mechanical properties of the welded joint. The causes of undercut include excessive welding current, improper welding gun angle, excessive welding speed, etc. Undercuts appear not only on the weld surface, but also during welding. The undercut of the non-capping layer will generally not affect the welding quality if it is not serious, but the undercut of the capping layer usually needs to be controlled. The generation of undercut is closely related to the workmanship of welding materials and the skill of operators. Slag inclusion is the molten slag that remains in the weld in the process of rapid solidification of weld metal before it has time to float out of the weld surface. The irregular geometric shape of slag inclusions is easy to cause stress concentration, which is often the origin of cracks. The causes of slag inclusion include insufficient welding current, excessive welding speed, improper electrode angle, too high flux melting point, incomplete slag cleaning between layers, etc. Solutions include adjust welding parameters, ensure that the electrode angle is correct, thoroughly clean the interlayer slag, etc. Incomplete penetration is the phenomenon that the root of the welded joint is not completely penetrated during welding. Incomplete penetration will reduce the effective working section of the weld, produce stress concentration at the sharp corner of the root, and easily cause cracks and lead to structural damage. The causes of incomplete penetration include insufficient welding current, excessive welding speed, too small groove angle, insufficient root clearance, excessive blunt edge, etc. Solutions include adjust welding parameters, ensure that the groove size is proper, and clean the groove surface, etc. Lack of fusion is the part between the weld bead and the base metal or between the weld beads that cannot be completely fused during fusion welding. The gap of lack of fusion is very small, similar to a crack, and is a dangerous defect. The causes of lack of fusion include insufficient welding current, excessive welding speed, improper electrode angle, oil or rust on the groove surface, etc. Solutions include adjust welding parameters, ensure that the electrode angle is correct, and clean the groove surface, etc. Burning through is a defect in which molten metal flows out from the back of the groove during the welding process, forming a perforation. The causes of burning through include excessive welding current, insufficient welding speed, excessive groove gap, etc. Solutions include adjust welding parameters, control the welding speed, and ensure that the groove gap is proper, etc. In addition to the common defects mentioned above, there are some other defects such as arc injuries, splashes, surface tears, abrasions, gouges, excessive sanding, etc. These defects have little impact on the structural strength, but will affect the appearance and surface quality of the weld. The causes of other defects include improper operation, equipment failure, environmental factors, etc. Solutions include standardize operating procedures, regularly maintain equipment, control welding environment, etc. Through this lesson, we've learned the common defects and quality control methods in robot welding in details. I hope everyone can apply this knowledge to practical operations, continuously improve your welding skills, and ensure welding quality and structural reliability. This lesson ends here. Through this lesson, we've delved into various defects and their causes in robot welding, and put forward corresponding control methods. I hope everyone can apply this knowledge to practical operations, and continuously improve welding quality. This lesson ends here. Thank you for listening. See you.